I've just knocked half of my desk on the floor again. Hey everyone, welcome back to Station 00, and what I hope is the end of, I suppose, the update drought for Project MJOLNIR, Project ODST, Project SPI, Project Marine, and everything else we've got going with the materials group at the moment. So, straight off the bat, I want to apologise before we really get into things. The last video that I gave you guys was on Christmas Day, and it was saying that the lack of updates was finally an end. We'd taken on some new projects, so there's going to be new updates coming more often. And we're now 8 months later, and you've heard very little since. So I must apologise for that. I'm not going to ramble on about excuses, but I am going to say that it's finally an end because I've completely changed the recipe on how I'll be doing these updates going forward. I was conservatively hoping to kind of back up a lot of progress on Project MJOLNIR specifically, but also some of the other projects, and then release a single big update that was going to be like 40, 50, maybe up to an hour in length, and really kind of show you the big progress that's being made. But I've kind of come to the conclusion, especially after reading over all of the comments from the prior updates, that I'm evidently leaving out a lot of information, a lot of subtle detail as to decisions being made and the process of development that I feel is detracting from the overall project, and I feel like you guys would like to know the aggregate nitty-gritty detail about things that are going on behind the scenes, so to speak. All the little decisions and compromises and rehashes and then dead ends that we then have to backpedal and go in a different direction. I think you guys would appreciate the complexities, the subtle complexities of that process more than me just coming up every 8 months at the moment and presenting something that's relatively large and impressive to you, and then going silent for another 8 months until the next thing. So we're changing the recipe substantially. There was supposed to be an update, a big update in May, and I broadcast that everywhere. And then I realised that there were some scale problems with some of the models, particularly for the exo frame for Project MJOLNIR, and realised I'd made a crucial error and had to go back and then redo a lot of the scaling for a lot of the models I'd made, and then that meant that all of the scaling was off, so I had to redo all the drill holes and bore holes and connection points and this, that and the other that would allow the frame to articulate and move and to connect to the armour plates. And then as I got into that, I realised how big of a task that was, and that's why I'm kind of now a couple months more down the line and you still haven't got an update. I said I wasn't going to go into explaining why and giving excuses, so I'll step away from that. In either case, the punchline is the previous format of big updates every 6 to 8 months, sometimes even longer than that, isn't working, and I think you guys would appreciate the subtleties. Sorry, I just slapped the microphone. I think you guys would. I do that almost every update. Have you noticed? It's because I talk with my hands. I'm off task. So I think you guys would appreciate the subtleties of the little decisions that are made along the way. So I'm going to break down the bigger updates that I was going to deliver every 6 months and more into much smaller, more focused updates on specific components of whatever it is that I'm dealing with. And of course, we have a lot of projects going now, so we have a lot of things to talk about. Now, the big update that was planned for May, that has now been delayed until now, but now it's now being split up, that had loads of information packed in and ready to go with it. And that includes a full lower body exoskeleton for MJOLNIR, completely reworked MJOLNIR armour courtesy of Galactic Armory, a reworked micro-refrigeration system for the BDU, early reworks of a version 2 helmet, upper body exoskeleton frame for MJOLNIR that was in early development, abdominal solutions for weight distribution and articulation, a fully metal UNSC marine armour, the highest fidelity SPI armor plating models that we can get our hands on, courtesy of Instinct Creative, a semi-powered exo frame for the semi-powered armor, the highest quality modular ODST helmet in existence, courtesy of 2 Penny Props, full ODST armor that is in development, passive powered exoskeleton frame courtesy of Nozzle Torino, a portable power supply unit that we've been working on quietly behind the scenes, renewed HUD systems with targeting and motion sensor integration, as well as early Spartan augmentation proof of concepts. So there was a huge amount planned for that massive update, but of course the format isn't working, and I feel like putting too many different things into a single update, it lessens the impact of those big innovations, but also kind of sells short the complexities and the discipline and the effort that went into getting to that place. So today we're not going to cover everything I've just listed. We're going to start focusing in on specific components and really go into the process, the mental process, the engineering, the design iteration, the compromises, and all the aggregate decisions that go into getting us to the place that we ultimately arrive at. I feel that's important to the process, but also I feel that you guys would enjoy that content, and also it gives you guys more information more often about what's going on, and doesn't sell short the complexity of what we're doing here, because what we are doing is complex. There's no two ways about it. So we're not focusing on everything I've just broken down in that long list of things that were planned. We're going to focus in, and today I really want to focus in at the foundation of the MJOLNIR exoframe. So we're going to really focus in on the design considerations for specifically the boot and ankle assembly for MJOLNIR, and how that ultimately is the foundational base of MJOLNIR, and all the technical considerations that have gone into what we've ultimately arrived at. So now I present that to you. So from literally the ground up, we wanted to make this as close to lore accurate as humanly possible, but still practical within context. So modelling of the sole of the boot to actually be lore accurate was kind of paramount, but also figuring out how to attach these components to MJOLNIR was instrumental in deciding exactly what we were going to do. With these, we decided to go with a dovetail joint in the toe and heel plates of the grip, and the grip themselves would actually be printed on a resin 3D printer with a flexible rubber resin, which is very similar to boot tread in regards to its hardness, toughness, its elastic modulus, as well as its grip coefficient. So these are actually extraordinarily close to standard boot grip in regards to how they grip, how they feel, and they will insert directly into the base of the boot via these tongue and groove connections, via the dovetail joints, and then they'd be effectively bracketed in. So as we wear through the treads, in theory we can just print some new treads and fit them. It's nice, quick and easy to do. It literally, I think the plan was to put a plate on here to hold them in place that would only be held in by 3 hex nuts or hex screws. So it would be a case of just undoing 3 screws, and you'd better remove different sections of the tread and then replace them with new pieces. So in order to get to that point, we needed to take the actual armour of the boots and engineer it to be able to receive the grip of the boots. So locating in and thickening this bottom plate to have the receiving dovetail joints was an important consideration. Obviously being able to really quickly release a holding plate so that they could locate into the bottom of the boots. So again, it's looking as lore accurate as humanly possible. We took a lot of inspiration from the cosplay community. These particular models are courtesy of Galactic Armory. They're extraordinarily modular in regards to how they're put together. All of the armor plates for the entire body now are from Galactic Armory, and we've reworked and re-engineered all of those armor plates to now be able to be modularly fit together with actual bolts and connect to the underlying exoframe as we develop it. So you'll notice we've already got screw holes or bolt holes in the base plate of the boot here that will allow long bolts to go up into the bottom of the exoframe as we develop it and anchor it directly structurally to the heel of the boot to channel as much of the weight of the exoskeleton above it through and into the floor. Now, of course, again, this is the foundation. We're talking about the foundation of MJOLNIR here. This is carrying all of the weight of all of the armor above it, plus the person wearing it. So this has to be able to bear weight. Now, of course, the long-term plan would be to get all of this machined or 3D printed in metal so that it's, again, hard structural components and able to channel them directly, to channel weight directly into the ground, as opposed to carrying the weight yourself as a user. But of course, in order to get to that point, we need to prototype the system first. It makes sense to prototype in plastics, 3D print them, because again, if we make a mistake and it's a 3D printed plastic component, it's really easy to go back, reiterate, redesign, and figure out where we went wrong and print new versions and new prototypes that can then effectively be supplanted into the existing model, and we're not wasting a huge amount of money in the process. Whereas if we sent all of this off too early to be completely fabricated in metal and then realised that we'd made some crucial errors, like I made with the scaling problem, then we have hundreds, thousands, even tens of thousands of pounds worth of material that is now effectively useless. We don't want to be wasting the budget. Now, strictly speaking, with this sole component, it should technically be in line with the actual edge of the heel here. It should be sort of supplanted sort of kind of underneath it where this actual wedge profile has been created and rendered into the model. That's where it strictly should be, but then again we're then encountering where a metal aspect, a metal component of the heel armour is going to be in direct contact with the ground, while the rubber surface underneath is being worn away. And of course, as it wears away, it only need to wear away by a millimetre or two, and then suddenly all that's contacting the ground directly is the metal of the rim, the perimeter of this boot, all the way around, in which case then all the forces of the weight above it are being channeled down into these bolt holes into this floating plate, and then being forced across into this little rim that's all the way around the edges of the boot, and that could quite easily put far too much shear stress on a joint here where this actual plate joins the rim. And that's very easy then to shear this entirely and have the entire boot armour raise up and pull away from the heel plate, causing injury to the wearer and severe damage to the armour itself. So the decision was made to expand this plate on the bottom, to thicken it up and to introduce the dovetail profiles into it, so that then when the heel rubber itself is inserted into it, there's a whole larger surface area in direct contact with the floor, and even when it does start to wear, we have 10 mils worth of wear until we get anywhere close to direct metal being in contact with the floor. And even when that happens, it's this much larger surface area in contact with the floor rather than these very small profiles on the edges. Now, of course, the toe of the boot is going to be taking some of these shear forces as well, particularly during the walking gait itself, but really the vast majority of the forces will be being channeled into the heel armour specifically, particularly just during static standing. But in either case, the same decisions were made to thicken up this lower sole area to allow these dovetail inserts to be engineered directly into the surface, and thus meaning that even with wear of the boot tread, we've still got 10 mils worth of wear and tear until direct metal is in contact. And even when that direct metal is in contact, it isn't just the edge of this armour plating, it's a whole surface, a whole interior surface, thus distributing weight over a much larger surface area and reducing risks of shearing off of this inner plate. Also affords us the ability then to engineer other devices into this, because we have more tolerance to play with as opposed to things being so tight. So it allows us down the line to implement into these voids in the sides here where I would believe the magnetic couplers are for the boots of Mjolnir that allow it to magnetically hold itself to a deck plate, for example. So I think they're channeled directly through these more circular protrusions from the grip. But again, we can re-engineer the underside of the grip, because this is, again, this segment here is a smaller segment of the sole. We can re-engineer these to remove these circles and be hollow entirely, to allow an electromagnet to actually protrude down through from this void in the upper corner here, directly down through the sole and make contact with whatever metal surface is beneath the boot, thereby anchoring the boot directly into place. I'm not immediately convinced that there is actually a magnetic coupler in the heel of the boot, as there's not really the space tolerance for it. I kind of liken the fact that the boot here in the Halo Infinite model is much wider near the ball of the foot, because it's distributing weight over a larger surface area, and there had to be some allowance for electromagnet modules to be fit into these little spaces. It makes sense for the toe to be the part that makes direct contact with the deck plate and remains in contact, as it would make it easier to pry that magnetic force off of the deck by bending the foot and lifting the ball, leveraging the electromagnets away from the deck via the tip of the toe, as opposed to putting them in the heel and potentially being anchored in place and not being able to even lift your heel to move. Otherwise, you'd have to shuffle along the deck plates. It makes sense to allow the natural bend of the foot around the ball to help and aid in that leverage to remove the electromagnetic's contact. For now, we're leaving it out just because really I don't see a use case in day-to-day aside from being literally on a ship with magnetic deck plates, which even in Halo lore that doesn't make a huge amount of sense, because it's suggested, heavily implied, that most UNSC ships are almost entirely made of titanium. Titanium isn't a magnetic metal, so putting electromagnets into the sole of the boot to hold onto deck plates or on the hull of a UNSC ship doesn't make sense, because titanium isn't magnetic. It won't attract a magnetic force and hold one unless the deck plates are made of like high iron steel. And generally speaking, on terra firma, you're not going to need electromagnets to keep you coupled to the floor, because, well, that's what gravity's for. The next thing that's puzzled me a lot about Mjolnir is the fact that the heel and toe of the armor are apparently completely separate, and particularly with the Halo 4 and Halo 5 models, you'll notice that the under armor of the Spartan, the Spartan's under armor suit, effectively bridges the gap between the hard armor of the heel and the hard armor of the toe. Meaning, strictly speaking, if a Spartan was to step on, say, a landmine, the explosion is being relatively well ablated and redirected around the Spartan by the armor of the thick armor of the sole of the boots, except right at the bridge of the foot, where there's only the under armor protecting it. So if you have no energy shielding on the soles of your boots when you're on terra firma, and there's no armoring, particularly at the bridge of the foot, and you step on something like an IED or a landmine, I mean, landmine, particularly if it's an anti-tank mine, I mean, goodbye Spartan anyway, but if it's an IED that's even remotely survivable, or an anti-personnel mine that's even remotely survivable, you're just increasing the odds that you're effectively going to have the forward portion of your foot from the bridge forward severed entirely, because the explosion has effectively been channeled into the bridge of your foot where there is basically no armor. So that hasn't made a whole lot of sense to me. So it made sense to implement a system, hence this hinge protrusion here. It made sense to implement a hinge that would still allow the foot to bend at the ball of the foot, so you can go through the normal walking gait. Also to be armoured to at least the same standard as the rest of the heel of the boot is. So I implemented this little hinge here, and then a coinciding insert to go into this that's held in place by carbon fibre pins that go all the way through here. So I implemented this plate that would effectively bridge the gap between the toe of the armor and the heel of the armor, but also provide some degree of armor protection. Now, I'm probably going to rework this again and actually make this angle underneath here slightly beveled, maybe raise it up from the center here as kind of a triangle profile. I don't know if I can kind of plot that out for you. It's going to be effectively something along the lines of something like that. So a triangle profile, because again then if something does happen from beneath, it's going to redirect those forces across and away either side. It's still obviously quite a shallow angle, but you don't need an immensely steep angle to redirect forces away from directly hitting a flat face, or at least the flat face of the underside of this plate. So this will locate in. Now I basically got two carbon fibre bars rather than putting a single one, because again, we got to think about assembly when we're actually putting this together, particularly when it's made of metal. How the hell are we going to do this and make it accessible, particularly when you're working with really tight space tolerances inside the boot itself? So what I effectively settled on is that this plate itself can slide into place here, like so, and that bridges the gap then between the heel and the toe with an armor plate. And again, like I say, I might bevel this slightly. I've allowed for space tolerances for it to allow it to flex. When you're designing anything, you have to design tolerances in toe, because if you engineer everything to one-to-one tolerances, then when you do actually 3D print or manufacture these, they won't fit together, because the inner diameter of this borehole will match the exact outer diameter of the pin that's supposed to go inside of it. There needs to be some tolerance, some play engineered in to allow these components to fit together. So I thought about getting a carbon fibre rod, effectively either 2 separate smaller ones or 1 longer one and then cutting it in half. And you'd insert it into this plate from either end and then push them in to this center void so that they're then fully immersed within the component. And then you slot that down in place and then push those pins back out into either side and then insert this device here into this hole that matches the profile, the inner profile, again with tolerances allowed, matches that inner profile and keeps those pins pushed fully into the receivers on the left and right side of the boot. And then just a single bolt can be put down through here, holding this component in place, because it actually physically slots in and kind of locks itself. That one bolt holds that in place and stops those pins from sliding back out, thereby maintaining that hinge connection between the ball of the foot and the heel of the foot. And then it's simply a case of bolting this rear receiver directly into the heel itself, or into the support system that's effectively the exoframe system that's effectively going to go over the top of this, so the foot will rest on the top. And of course that's when you really get onto the real meat and potatoes of the ankle joint. Now the ankle joint is an interesting joint because it is just a standard hinge joint that allows the foot to flex up and down, particularly during walking. Obviously you've got the ball of the foot that bends as well, but the ankle itself is just really a hinge. But you can also roll that joint. You can majoritively only roll your ankle one way. So you can roll, for example, your right ankle outwards. You can kind of roll and allow your right foot, the sole of your right foot, to turn in towards the left. That's rolling your ankle, which I believe is called ankle anterior supplination, something along those lines. Just basically the ankle roll. But you can't do it the other way. You can't roll, for example, the sole of your right foot out to that way without moving your upper leg. So it's a kind of a relatively inhibited joint. But of course the decisions that we then had to make in regards to the weights that we're dealing with, the range of motion that we're dealing with, is how close do we want to get to mimicking the full anatomical scale of motion within the ankle. Because again, this is a joint, a singular joint for our bodies. It carries all of the weight of our bodies above it, which is why rolling your ankle and spraining it hurts so much, because you have the entire weight of your upper body, or everything above it, is going down through now an unsupported joint at an unnatural angle. And of course if you then add to that the weight of the armour, let's say the estimations of Mjolnir's weight are correct, and a finished suit Mjolnir is going to weigh a half a metric ton, you can seriously sprain and in some cases break your ankle through rolling it just with your own body weight. Imagine what would happen if you did the same thing but with a half ton rested on your shoulders. So we had to make a decision. How important is ankle roll? Are we going to need it that much? Is it really that necessary in the range of motion that we're going to be performing with Mjolnir? Now of course this is supposed to be lore accurate, so we're supposed to mimic range of motion majoritively while avoiding hyperextension. So all of these considerations have to be made, and then we have to think about how the ankle flexes when we're walking. And of course, if there's uneven terrain, your foot naturally goes through these flexes and supinations during walking, because you have to accommodate for uneven ground surface. So do we necessarily want to limit the ankle joint to just a hinge, just a basic bending of the ankle, and thus lose the ability for the foot to naturally adjust to uneven terrains, and particularly being able to stand in like power stances that we see Master Chief frequently standing in, and you can see that the ankle naturally rolls. Are we going to want to limit that to the point that when you stand in those angles, the sole of your foot lifts off the floor because the ankle joint itself is static and fixed? Or do we want to allow a little bit of play? These are considerations that had to be made and thought about at length. Now, early concepts that I had of doing this was something similar to this. So these two lower booms would go down into effectively the sole or the heel of the boot, something like this. Okay, but of course there's a problem in doing that. One, the shear forces at the joints here. You've got the weight of the armour above. So if this goes up into the shin armour, that would allow your ankle to roll, but it also allows your ankle to roll the wrong way. The thickness of these bars isn't going to support the suggested weight that it needs to above it. These are far too thin. Even if they were made of titanium, these are far too thin to deal with the shear forces involved. Again, we're thinking about how forces travel through the frame. So if this is going up into the shin and there's a weight pressing down here, that means it's putting flexion on this joint, but it's also bending this joint unnaturally, and it just takes a little bit too much. You can break this joint here, which means now the entire weight of the upper armour, with that absent, is now on your ankle, not on the suit. Or even if that one doesn't give way, you're putting a leverage onto this joint, and again the shear forces of the weight being pushed down here and then having to be pushed and travelled down into the heel, this isn't becoming of being able to easily and safely channel those forces. So we needed to overhaul this early concept significantly and really beef it up, make it a much more substantial joint. And the first few ideas really did lose most of that additional ankle roll that is allowed within your natural anatomical ankle, and limiting it only to a simple hinge joint. But of course, in so doing, again, we lose a huge amount of fidelity, a huge amount of range of motion in the ankle, particularly when dealing with uneven surfaces. Now, we went through numerous ideas of using maybe compliant mechanisms in the heel and the ball of the foot to allow the foot armour itself to articulate independently of the ankle, so you can still maintain traction and an angled foot surface on uneven terrain, but still maintain that single inline hinge ankle joint. But it felt unnatural in our early prototypes, really unnatural. You feel like you're walking on like a knife's edge or a tightrope. You can feel there's uncertainty, and it's too forgiving on either the roll in or the roll out of your ankles. It feels very peculiar. So the thoughts then were, okay, do we just stick with a very simple ankle hinge and don't go anything beyond that? And we did actually pick up some ankle braces to kind of figure out exactly how the anatomics of that would work, where it's just a hinge here, but you have no ability to roll the ankle. If you're walking and then you're hit with uneven terrain at, say, this angle, the foot is going to either sit unsteadily on that surface, or you're going to have to move the entire body or the entire lower leg to match the angle of that uneven terrain. Again, this isn't ideal for both surface traction for the boot, channeling the shear forces through the armour itself and through the exoframe itself into the ground. You need as much surface area in contact with the ground as possible at all times to avoid serious injury or damage. And again, the system itself, the exoskeleton frame itself, needed to be beefed up considerably. Now, going with these thicker bars, these bars are 52mm, just over 2 inches across, and around 10mm in thickness. Now, interestingly enough, once made of titanium, one of these bars is capable of supporting 5 tons. So having 2 of these bars per ankle means that a single ankle joint is capable of supporting up to 10 tons of shear forces. Now, that might seem like we're massively over-engineering it, but sprinters in peak forces during maximum sprint can put 4.5 to 5 times their body weight in forces into the ground as they're running. So if you amplify that out for Project Mjolnir, again, based on the estimations that the armour itself is going to weigh about 500 kilograms, that means the forces that we're dealing with here are up to 2.5 tons worth of force during a mid-sprint. And of course, you're not going to have both feet in contact with the ground at all times, allowing the weight to be distributed across both feet. During walking, jogging and running, those forces are going to swing wildly from left foot to right foot and back again. So the hinges responsible at the ankle need to deal with all of these massive shear forces of all of the weight of the armour above it and remain fully structurally intact, but allow the range of motion that is necessary. I went back and forth for weeks on different designs for these hinges. Again, taking into consideration that we're going to need attachment points. For example, here with this one on this forward surface, we need attachment points for bars, spars, and articulators that would then go to the toe of the boot. But I mean, ultimately, I abandoned these designs specifically, but we needed these protrusions. But we didn't need this to drift too far out of phase of the foundation of this bar, because again, if this goes too steep of an angle, when the shear forces are channeled through it, it puts a stress point right around here where where this angle is in play. And if there's too many stress forces here, it can fracture and split across. We do not need that. So there were 2, maybe 3 solid weeks of me completely and utterly mincing my brain on the day-to-day basis, trying to figure out exactly how I was going to allow the ankle to flex through normal range of motion just in general hinge format, but also allow a degree of roll of the ankle, but structurally limited to a point where it still allows the foot to adjust to uneven terrain, but doesn't risk the shear forces going too far off of center to risk damaging the joint, shearing the joint, and forcing the person to experience the weight of the armor. And again, this is on the basis that our estimations are that the armor plating alone for MJOLNIR in titanium are going to weigh around 500 kilograms. The frame itself is going to be made out of titanium as well. That's going to add a significant margin. Once all is told, it's more likely that a suit of MJOLNIR with current technology and current materials is going to weigh closer to 1 to 1.2 tons. So these are joints that really need to stand up to the rigor of movement. Now, the design that I ultimately settled on was not unlike this idea. Initially there was an idea with 2 bars going down into the heel and then a single one going up into the shin. But of course, as I thought about it more and started designing it, fleshing out and beefing up these structures to deal with the shear forces involved, I realised this still has all those problems with shearing at the joint and loading this particular ankle hinge joint in an unnatural way. So effectively, we kind of flipped it upside down and worked instead on this premise where we have a single bar, effectively at the Achilles tendon, that allows that degree of ankle roll because it's in line, planar line with the natural roll of the ankle, but structurally limit it. So this bar itself was thicker and more beefier to accommodate for the additional weight that it was dealing with, but also while structurally limiting the risks of hyperextension in either direction. In fact, it completely stops the roll of the ankle outwards and only allows the natural roll of the foot inwards, but only up to about 25 degrees. And this is close to what I settled on. Not entirely, but it's damn close. And what we effectively have here is a lower bar that goes down into the heel that channels all of the major shear forces. It's a thicker bar, so it can deal with much higher forces. This single bar on its own, the way that it's designed, the way that it channels the forces that are involved in it, allows the distribution of around 9 tons on just a single bar like this. From here, we engineered in a small wedge at the back here, so that where this ankle cradle rests with the joint planar in the right angle and the right axis to allow the roll of the joint, it would completely prevent, mechanically, due to this wedge here, this from rolling outwards, but allows, just past the pivot point, a roll inward. But once this underside face here moves down and makes contact with this face here, it stops. And then again, the forces are being transferred through that wedge directly into the plate and down into the heel. And that deals with the shear forces in a much more organic way, still allowing the natural flex of the ankle, structurally limited though it is, and also allowing the natural roll of the ankle, but also structurally limited to prevent hyperextension. It was then immediately following the prototyping phase where these went onto a printer, well, actually a new printer, and actually that's a good point. Little segue, I need to thank Anycubic. They sent me the Kobra 3 Max, their newest large format 3D printer. Phenomenal. It is so ridiculously quick. It's 3 times faster than the previous Anycubic. So I had the Kobra Max before this, the first one. This is the Kobra 3 Max, and this thing is literally 3 times faster than the original one. It is actually intimidating watching that thing move around because it's quite a large machine and it moves ridiculously quickly. It also has like a counter vibration system built into it because of course it's a lot of mass moving around very rapidly. It has a motor in the bottom that's got an off-centered weight that actually rotates at the opposite temperament of the way in which the arm itself moves around to offset the natural wobble of the machine due to that inertial change of the arm moving around, which means it's effectively got built-in inertial dampening. Incredible innovation. Back on task. So I prototyped this ankle assembly with this particular ring joint, and I realised in designing it, we'd have effectively 2 bearings per joint. And 1, that's a lot of additional weight, and 2, it's a lot of unnecessary complexity. So I realized there's no real necessity of making each of the joints in that particular manner, and we can actually make each respective joint only 1 bearing assembly in one part of the joint and then a pin assembly in the other part of the joint, rather than trying to figure out how to put 2 bearings into 2 separate components and then mount an axle to go through the center of both of them and then have them clamp in such a way as to prevent it coming loose and slipping and this, that and the other. It made sense to re-engineer it in such a way where the pin itself was mounted onto this ankle cradle, and then in so doing we could mount the bearings onto the supporting bars that then go up into the lower shin and down into the heel via the Achilles support bar, so to speak. And because of the way that the assembly is done, just the natural limitations of the armor and the fact that it won't allow the lower bars to move apart means the joint physically can't come undone. It's being structurally held in place, which means we need less bolts, less fixings, and less this, that, and the other that add unnecessary weight to keep these particular joints in play. So we ultimately re-engineered this lower ankle cradle to become instead an ankle pinion cradle that would then interface with the bearings that I'd already pre-bought for those respective ankle joints. And then, like I say, with the structural limitation of the upper shin armor and the heel armor itself, it prevents the joint from slipping out. So we could get rid of that joint entirely and instead slot this one down into place, allowing for all the tolerances that are necessary, allowing the bearings to be set, still keeping to those structural limitations at the ankle joint itself, and still having the hard points in place for connection to the toe of the armor for the sakes of supporting spars and to allow the flexion at the ball of the foot. And that is ultimately what we printed on the 3D printer, and then it was just a case of printing the other components and the other parts of the boot armor to get this to all work together. So it meant taking the earlier concept of the boot armor, which is the stuff that you guys would have seen on the social media posts showing this earlier range of motion ankle flexion, which again I've made numerous social media posts about. It meant getting rid of this armor assembly entirely and then working with Galactic Armory's assembly and bringing the boot together. Now the boot here has, obviously this has now been mounted, the toe cover has effectively been mounted in place. We have the ankle joint in play. Again, this is the left boot, okay, so it allows the natural flexion of the foot and the natural roll of the ankle inwards, but still completely deals with, there's very little play in this joint, and particularly once we end up getting this 3D printed or machined in titanium, there's going to be even less play involved in this joint. And again, with these we'd have bearings that mesh over the ends of these, which would locate into these 3D printed components that actually locate up into the lower shin armor. And this still allows the bending of the boot from the ball of the foot due to that plate that we've installed inside, that still allows the bending of the toe of the boot and still has our resin 3D printed boot grips on the bottom that are canonically accurate. It still allows the full range of motion that you would expect for the ankle itself to bend and flex here, but limits the roll of the joint within reason so that you can still roll your foot and still adjust to uneven terrain, but it doesn't allow that to go too far. So I'm really happy with the way in which the ankle assembly came together, and the considerations we had to make with dealing with the shear forces involved completely thrown out. I mean, you can see it's like a day and night difference between something like this that was originally planned. So beefing this entire assembly up and making it in such a way where it can deal with large amounts of force, particularly with 3D printed components or machine components and out of titanium, these things are going to be able to deal with up to 10 tons worth of shear forces. And again, once you include the armor plating or the exoskeleton, the internal exoskeleton frame that we're building now, that goes all the way up through the entire armor and supports the weight and distributes it and allows hard points and connection points for articulators, so you can actually physically move in it with power assist, we're talking easily it's a ton and a quarter, maybe even pushing a ton and a half. I'm gonna go out on a limb and say we're probably gonna end up evening out at about 1.5 tons. So that gives you more of a focused look at what we've been doing with specifically the ankle joint and the considerations and technical concerns and structural and anatomical limitations that we needed to impose. It gives you hopefully a better understanding of how deep we have to go into certain considerations for certain aspects of the design. Again, this one focused in specifically on the ankle joint. There will be a video to chase this one that will explore what happened above that, what happened into the lower shin, into the knee, into the thigh, and all the way up to the hip articulation. And then we'll flip over and do the upper body, and then we'll make them together with the abdominal systems with numerous videos going forward, as opposed to just big updates every 6 to 8 months. Also expect some updates coming very soon with the real-life marine armor that's actually genuinely made of metal. This is an ongoing project. This is quite a lot of development work. It's gone into doing all of this over a very short space of time. This will obviously be worn over fatigues. The fatigues themselves, we're looking at kind of up armoring with Kevlar, shear thickening fluids and things like that. But we'll tackle all of that with Project Marine. Again, like I said, the big list of things that we've been doing. There's a huge list of things that we've been doing, and there are updates coming for all of it, thick and fast now, as opposed to every 6 to 8 months. So again, apologies it's been so long. A lot more progress to come. I'm kind of hoping conservatively I can get about a video a week updating you guys on all of the different, I mean, you can see there's just components led everywhere here, like over here. So these are all like separate components now. This is completely separate, you know, and they nest together. We've been busy. There's been a lot going on to get all of this, you know, coming together the way that it is, and that's not to mention all the other considerations we had to make for like range of motion of certain joints and things like that. This is just ridiculous. All of this coming soon. All right, so I'll have videos thick and fast, hopefully one a week for however long it takes now into the future to get you guys up to speed with what's been going on, and hopefully by then we'll have even more progress to show off. So there's been a lot going on, a lot more to do. And I'm excited to share all of it with you guys. So again, thank you so much for your patience and understanding. Thank you so much for continuing to support the channel and the projects that we've got going on via the GoFundMe, via the Materials Group Patreon. I've had some messages from a couple of people on the Patreon regarding merchandise. So if you are a member of the Materials Group Patreon and you haven't received anything for whatever reason, reach out to me either on Patreon or on Discord and let me know what you have and haven't received, because I can then figure out what the hell is going on with merch fulfillment behind the scenes, because some of it is fulfilled by Patreon themselves, some of it's fulfilled by me. I want to make sure things are getting to where they're supposed to be getting, because again we've had ongoing issues with postal stuff. Spartan John can attest to that. We've had, you know, I'd sent him something back in December, and customs lost it, and they're blaming everyone else but themselves. It's just, and there was tracking on it, and also it's ridiculous. It's a whole thing. It's awful. But let me know if you haven't received stuff, or what you have. If you have received some stuff, tell me what you have, what you haven't, and this, that, and I'll figure it out. If you are, and only if you are in a position to help, to donate through the GoFundMe or to become a patron for the Materials Group to help keep pushing this forward with all the updates we've got planned and everything else we've got planned for it. If you're in a position to help, please do. It's massively helpful, gratefully received, and we've made some incredible progress together. If you can't, continue to watch, continue to like, continue to share, continue to subscribe. It all helps. Thank you so much. I hope you guys have enjoyed this kind of very focused in breakdown, and I've got loads lined up now for the coming weeks for you to really get into. It might have been a little bit rambly in places, but I think I did okay. Anyway, thanks again everyone. Thanks again to all the people that have been involved in helping get these projects going in the right direction, including Galactic Armory, Instinct Creative, Two Penny Props, Nozzle Torino, Harbinger, Anycubic. Thank you to all of you. Thank you to all the people who continue to support. Thank you. Take it easy, everyone, and find peace in the domain. Thanks for watching. If you enjoyed this video, kindly tap that like button, and if you're not already subscribed and want to see more stuff like this, be sure to subscribe so you don't miss future uploads. Pop a comment down below telling me what you thought of today's video, or if you want me to cover something specific in the near future. I want to take this opportunity to thank and give shoutouts to my patrons and YouTube supporters: Spartan10148, my singular contender class Ancilla, the triumvirate of minds within my installations Metarch, Falcon, Jordan and Poseidon, my 7 installation monitors Sophia, Ashley, Esoteric, Spartan1029, Chris, Orion and Shane, the crush of sub-monitors Legion, Ryan, Lebrat, Spartan0137, Element 0, J3, Cult, Evermore's, Personal Devil, Scion Esports, Phantasma, Ashton and 191 Shaken Lightbulb, my fleet of Strato Sentinels, my most loyal of Enforcers, and every single one of the awesome people supporting the channel over on Patreon. My Tier 0 Transcendent YouTube members Spartan137, again, Maury, Jimbo and Balaz, and all other YouTube members keeping my installation functional on that glorious vacuum energy. I cannot thank you all enough. Shout out to John because... And if you like what I'm doing here, consider supporting the channel on one of the support links in the description to net yourself some tasty merch and help keep the channel going. Take it easy everyone, and find peace in the domain.